It never fails. You start writing that coroutine and oops, Kotlin says you need a scope. Well, I know it can feel like an obstacle, but once you understand all of the advantages of coroutine scopes, you'll never want to write concurrent code without them. In this video, I'm going to show you why coroutine scopes are a good thing. Here's some very simple code for inspecting a building, and you can see I'm using global scope here. And global scope is as close as Kotlin gets to letting you not have a scope. It basically means run this coroutine all by itself. So it's a quick way to get your code to compile, but the problem is that when we run this, it doesn't actually end up printing anything. So what happened here? Well, the main function created these 3 coroutines and queued them up to run, but as soon as it did that, the main function was finished, and that means the whole process quit before these coroutines ever even had a chance to run. If we want to see the output from these coroutines, we're going to have to get the main function to wait long enough for those coroutines to actually run. Well, one way that we could do that is to add a call to thread.sleep at the end like this. And now when we run it, the process stays alive long enough for those 3 coroutines to complete. Now, of course, we're making an assumption here about how long these coroutines are going to take to run. If one of these inspections were to end up taking a little bit longer than the others, then it could still end up in the exact same situation as it was in originally, where it's not going to print out in time. Of course, we could fix this by updating the call to sleep to something much larger in hopes that it'll be long enough for any reasonable inspection to take. But now our main function is going to wait a lot longer than it needs to wait. So here you can see all 3 of them have printed out, but the main function is still waiting. And there we go. So what we really want is for the main function to simply wait to return until all of its coroutines have completed. And that is the first and most important thing that CoroutineScope gives us, the ability to wait for its coroutines to complete before moving on. So instead of launching these coroutines all on global scope, we can group them together under a single coroutine scope. And here I'm going to use run blocking to do that. Now, run blocking creates a coroutine scope, and inside of its lambda, that scope is the implicit receiver. So in other words, when we call launch like this, it's the same as writing this.launch. But as you know, we don't usually need to explicitly write out this, so I'm going to take that back off. And thanks to coroutine scopes, we no longer need to wait for some arbitrary amount of time. So we can take off this thread.sleep entirely. And when we run this, all 3 coroutines are going to run to completion. And then you can see the process finishes when they're done. And no matter how long these coroutines take to complete, the run blocking function won't return until they've all finished. And of course, the main function is not going to return until run blocking returns. So that means our process stays alive for exactly as long as it needs to. It never finishes too soon, and it never finishes too late. CoroutineScope is what Kotlin uses to achieve a feature called structured concurrency. And what you saw here, this ability for a coroutine to wait for its children to complete, that is the most characteristic feature of structured concurrency. That's what makes structured concurrency what it is. Now, even though this is the most essential benefit of using coroutine scopes, it's not the only one. For example, here's some code for a much more elaborate inspection process. You can see that each inspection now has a few subtasks under it. And as you can see, I'm using the CoroutineScope function here, here, and here to make sure that the coroutines inside it fully complete before printing out that the whole category is complete. And I'm going to run this just so you can see what the output actually looks like. We're now printing out when each subtask starts, when it finishes, and when the entire category of inspections has finished. And then all the way down here at the bottom, we print out that everything has completed. Now, it's possible that we'll need to cancel one of our inspections. Maybe this inspection is no longer needed, for example. So let's add a delay of 500 milliseconds and then cancel. And we'll need to pull in the import here. And if coroutine scopes didn't exist, we would have to manually keep track of each coroutine and carefully cancel the right ones in response to a cancellation event. But thanks to CoroutineScope, When the outer scope is canceled, it'll automatically cancel each of its children. So when we run this, we'll notice that these tasks will all be canceled, and the rest of the inspections will run to completion just like we wanted. So cancellations are another benefit of structured concurrency, which we get because of coroutine scopes. Now, rather than simply canceling the job, sometimes something goes wrong. So I've updated the code here to throw an exception right here after 1.5 seconds. When we run this, the exception will make its way up through its parent coroutines and scopes all the way to the main function here. And along the way, any child coroutines that haven't already finished will be canceled. So let's watch that happen. So thanks to structured concurrency, when an exception is thrown, we don't have to manually hand off that exception to parents, nor do we have to concern ourselves with canceling the children in response to exceptions. All of that's just given to us automatically. Well, what would this code look like if we didn't have structured concurrency? Well, we can use global scope on each call to launch, like you can see I'm doing here, which makes it effectively as if we weren't using scopes at all. And when we run this, we can see that the outer coroutines complete right away. They didn't wait for their children, so they incorrectly told us that each one of these passed. The exception is thrown, but all of the other coroutines were completely oblivious to it. So without structured concurrency, our coroutines are off the leash. They're not accountable to anyone. And unless you were to manually write a lot of code here, anything that goes wrong would likely just end up in the black hole of a log somewhere. So even though coroutine scopes can seem like an obstacle, you really do want them. The most important benefit that a coroutine scope gives us is that it prevents control from moving on until all of its children have completed. It also automatically cancels its children whenever a parent scope is canceled. And when an exception is thrown, that exception will get handed up to the hierarchy, canceling the children along the way. Now, of course, there's a lot of nuance to how all of these things work. For example, we need to carefully close any open resources whenever a coroutine is canceled. We can use supervisor scopes to isolate parts of our coroutine hierarchy. We can install last resort exception handlers and so on. So if you're ready to go deeper on these things, I would love to help you nail down your understanding of structured concurrency and everything else about coroutines. I've left a link in the description of this video so you can take a look at my Coroutines course and see if it would be a good fit for you. In case you do decide to join the course, I've also left a promo code. It's valid through the end of the month, the end of 2025. In the meantime, I've also got a lot more videos lined up for you, and I can't wait to get to them. So be sure to subscribe to this channel so that you don't miss them. Thanks so much for watching today, and I'll see you next time.